Hello everyone. Now, we will continue with the significance testing. In last segment what we have discussed the significance testing of mean, difference in mean, and now we will discuss the significance testings of dispersion. If the mean is different from the nominal mean or mean of two data are different, in last segment we have seen that we can take proper action. We can either reject or we can accept depending on the significance testing. If the variation is difference is significant, then we can take action. But there may be another situation where the mean are not that different, maybe same, almost same. Suppose we have say 20 count yarn, 2 yarns we have taken, both the yarns the mean value is giving say 20, but in one yarn the standard deviation is much higher than other. Now, the problem is that which one has to be accepted. Same problem that higher variation should we right away reject, it is not that. Before that we have to do the significance test. Here the problem is that significance test of dispersion or variability. So, and variability is expressed mainly in terms of either standard deviation or coefficient of variation. Now, this problem is that single standard deviation with large sample. What does it mean single standard deviation? Here single standard deviation means we have the nominal standard deviation and the sample has got its standard deviation. So, a certain yarn has a mean strength of 45 pound when tested in a Lee form, that is 45 pound is the mean strength. Its standard deviation is known to be 7.2 pound, means it is nominal standard deviation. So, 45 pound is the mean strength and the standard deviation is 7.2, that is the variability. 50 Lees are tested. So, from there this is the known value 45 pound and 7.2. Now, sample is taken 50 Lees are tested, and although the mean strength is not significantly different from 45. So, we are not bothered about mean strength. So, then suppose the yarn is giving 45 strength, but the standard deviation of the sample is 9.4. Our targeted nominal standard deviation is 7.2, that is it is acceptable, but it is giving 9.4. Now, our problem is that to know is the variability of the sample is really greater than the bulk sample. So, bulk samples is 7.2 standard deviation, now it is 9.4. The treatment here will be exactly same as we have discussed earlier, but the formula will be little bit different. Here the standard deviation we are measuring. Now, this is the problem. Here the given data is n equal to 50, mean strength is 45 and nominal standard deviation S, capital S is 7.2 and standard deviation of sample small s is 9.4. Now, step 1 is that the calculate the standard error of standard deviation. Now, earlier what we have done? We have calculated the standard error of mean. Here we are now trying to calculate the standard error of standard deviation. The formula is just here, it is instead of n it will be 2 n. Okay. Standard error of standard deviation is standard deviation of sample divided by under root 2 n. Here one thing we should remember, here we are not talking about the standard deviation of population. We have two values, one is population value, another is sample value. Here we will be taking standard deviation of sample by under root 2 n. Okay. Now, standard deviation of sample is 9.4 and 2 n, then it is coming out to be 0.94. This is standard error of standard deviation. Okay. And then rest the process will be exactly same. So, we will calculate the t value. T value will be the difference between the standard deviation, because we are now trying to calculate the difference between standard deviation, it is not the mean. Okay. There is difference between the standard deviation by standard error of standard deviation. So, difference is capital S minus small s by standard error. So, the t value has come out to be 2.3404. Okay. This is the t value. Now, this t value we have to compare. Now, compare this t value with the 1.96 and 2.54 as we have seen earlier for 5% and 1% confidence level for large sample, that we have seen 1.9. So, this once we compare, so 2.34 is compared, it is higher than 1.96, but less than it is 2.54. Okay, 58. So, the conclusion is that although there is some evidence of a difference in variability, it is only significant at 5% level. Okay. So, it is not significant at 1% level. So, what we should take action, we may or may not accept, okay, but in normal case we may allow it to go, okay, if there is no extreme problem. Okay. Next is that earlier one was the single standard deviation with large sample. This was the with a large sample. Next one is single standard deviation with small sample. Now, the problem is the standard deviation of least strength of a yarn is 2.3 pound, but the sample of 13 small sample 13 bobbins from a lot is tested and the standard deviation of the sample is 3. So, it was 2.3 is the nominal and 3 is the actual we have got. Okay. Now, we have to do is the ring frame producing a yarn whose strength is more variable than usual. Okay. This is the problem. Now, here the thing is that in this case as it is smaller sample, we can definitely go for the standard error principle as we have done earlier. We can solve this numerical based on exactly same earlier value. Only thing is that here the earlier case it was the large sample, the t value was taken based on the degree of freedom of infinity. Here we have to take the t value based on the degree of freedom 13 minus 1, that is 12. On that basis we can test, we can do the analysis, but as it is a smaller sample we can use another technique. This technique which is simpler one, much simpler one, we do not it actually it is faster one, it needs very small calculation, that is that it is a F test we can carry out. Okay. So, the data which is given here, n is 13, nominal standard deviation of the ring yarn is a 2.3, it is a nominal standard deviation which is targeted, and standard deviation of sample is 3 is the standard deviation of sample. Now for F test we have to calculate the variance. F is, as we have seen, F is nothing but the variance ratio. Okay. So, then we calculate the variance. What is variance? Variance is the square of standard deviation, and now the V 1 we do not know whether it will be V 1 or V 2, V 1 will be always higher. Okay. Here we have seen 3 was higher, 3 is the sample standard deviation, that is why V 1 we have taken as 3 square 9, okay. And V 2 it is lower, it is a 5.29 which is 2.3 square, which is the nominal standard deviation. Now, what we have to do? We have to simply take the ratio. So, calculate F, F is the ratio of the variance of greater variance, that V 1, and it is a smaller one. So, this is the ratio. Now, this F value we have calculated, this we have to compare with the table F value. This is the table F value at 1% level, okay, 1% level. So, what is the degree of freedom here? Degree of freedom is the 12 for V 1, that is for sample 1, and infinity for this one, this value. It is the, that means it is coming out to 2.18. It is not clear, but it is a 2.18 value at 1% significance level. Similarly, for 5% significance level, it is 1.75. Now we can compare with the value which we have got, that is the at that is the degree of freedom is n minus 1. So, here n the degree of freedom will be 12. So, against 12 we have seen, and the larger for population it is a, that is the degree of freedom of 2, second that is the infinity, it is then, and here it has come, it is F is 1.5 at 1.75 as we have seen from the table, and 2.18 for 1% level, and our calculated value is 1.7, which is less than 1.75, okay, and that means insufficient evidence is to provide that variability is not there. That is the case. Now, the tricky thing is that here we have two options. One is standard deviation option, by standard error method we can calculate, t test we can have, and F test. Now, obviously, as I have told that F test is the simplest one, needs least calculation. So, that means always we should prefer F test, at least for the variability test. For variability, significance difference is variability, but F test has got one limitation. In this problem, in this numerical, I will just come back once again. In this numerical, it is a small sample, one small sample, and we are comparing with the population which is larger one. F test only can be done and can be actually performed if the sample size is small. For large, both large sample, suppose our sample size is large, then we cannot perform F test. Now, the question is why? Now, you just see, it is very tricky, because it is a always people would like to test the without calculation. Now, here if you see the F value here for say both the sample and both the samples or the sample size is high, sample size is very high, that is infinity. If we see the infinity value of for sample 1, okay, and for sample 2 it is a large sample, it is a infinity. And what will be the f value? Here if you see the f value, here f value becomes 1. This is true for at 5% level also, 5% level for both infinity of degree of freedom for 1 and degree of freedom 2, it has become 1, which is actually against our assumption. What was our assumption? Assumptions are the f should be more than 1, always it will be more than 1, because f value 1 exists only in one case, only when the standard deviation of sample 1 and standard deviation of sample 2 are exactly same. In that case only f value will be 1, but if the standard deviations are same, then we do not need to calculate the significance test. So, that is why f test is only carried out in case of when the data number of data are smaller size. Okay. Now, we have done all this numerical solved. Now, this is for your homework I have done. So, you can simply note down this numerical and test, you can try using the form theory or using the all these problems we have solved. Just I will read all these things. 100 ring bobbins are tested for count and the mean count is found to be 34.2. The nominal count of ring frame is 34.0. Okay. Can we conclude that the frame is really spinning off count? That we can, okay. Standard deviation of sample is given 0.62. Next numerical, a sample of 12 ring bobbins are tested, this is small sample. Okay. Example, are tested for count and the mean found to be 94.2. If the nominal count is 92, is the machine spinning to find count? This type of numerical we have already discussed. Standard deviation of sample is given, and this is also we have discussed. So, difference between means of two large samples, two yarns, yarn 1, yarn 2 details are given. Okay. Is the difference is real in the least strength? Similar we have given 60, 70 we have seen. So, same problem, same way one can solve this problem. Another problem is the difference between mean of two small sample. Here the samples are smaller. In this case only one difference is that we have to calculate the degree of freedom. Earlier case we have used the larger sample, we use the degree of freedom as infinity. For small sample what we have to do, n1 plus n2 minus 2, that is the degree of freedom. So, in this case degree of freedom we have to see t test, we have to refer t test for degree of freedom of 18. Okay. For that we can test, and rest other systems are exactly same. So, here it is a untreated yarn of sample which is given 48 strength, and after treatment it has become 46. Now, we would like to know whether the treatment has given treatment has weakened the yarn or not. Okay. This is, that means, if it is the question that chemical treatment weaken the yarn, that means whether this strength has the difference in strength is actually significant or not, that we have to test. Okay. Now, standard deviation with large sample. Okay. The nominal count, this type of problem we have already discussed. The nominal mean least strength of yarn was 42 pound, the nominal standard deviation is known to be 64 pound, 40 leaves were tested, standard deviation of the sample was found to be 8.6 pound, although mean strength are same. Is the variability of the sample is really greater than the bulk, the same similar yarn. And sixth one is the usual standard deviation, that is nominal standard deviation of count of yarn is 1.5, but the sample of 9 n is 9, is tested and standard deviation is found to be 2. Okay. Is the ring frame producing yarn with a more variable or not. So, here we can as it is a small sample, we can use either standard deviation, standard error or t test we can, or we can use the f test. Okay. And here standard deviation to large sample. So, here we have to do the as it is large sample, we can do the t test as we have discussed earlier also. Okay. And standard deviation to small sample, here we can test f test also. Okay. So, this is the wave to edge strength of 2 fabric samples was tested to see whether the change in weft yarn, that yarn has been changed in the same loom and for the same set of work had affected the variability of the strength. Okay. So, that is the strength of standard deviation of strength of fabric A was 6.5 and calculated from 9 test result n 1 equal to 9, and if the fabric B was 7.5, n 2 equal to 11. So, we have to test. So, that is the variability. Here we can see standard deviation of this B was higher. So, we can assume the square of this as V 1, that is the variance 1, and variance 2 will be this one. So, 6.5 square. So, the f value will be 7.9 square by 6.5 square. We will see against that the horizontal line, we will see that 11 minus 10 degree of freedom, 10 against 9 8. So, 10 against 8, the whatever value we are getting, that f value we have to compare. Okay. So, in that way we can do this solve these numericals, and we can try similar numericals also. And with this we will finish this segment of significance test. Thank you.